Hi everyone and welcome back to my channel. So today we will be doing some continuing our lecture of kinematics. Okay, so this is the third part. In previous video I have covered the kinematics graphs. So if you want to watch that video, I'm giving the link on the in your description. You can see that. You can watch that video as well. So today we will be learning about circular motion as well as projectile motion. Okay. Circular motion is very basic. Okay, when an object moves in a circular path, okay, then it is called a circular motion. Okay, if it's a car is moving in a circular path, okay, which it means that it is a circular motion. So that one thing you need to remember is that why velocity is not constant in circular motion. Okay, it is because the direction is always changing. If you watch my previous videos of kinematics, I have told you that the velocity depends on two things, speed and your direction. If any one thing changes, one quantity changes, the velocity will not be constant. Okay, so we can see that if a body is moving in circular motion, right? So it's changing its path, it's changing its direction at every second, at every instant. Although its speed is constant. Okay? Speed is constant, but the direction is changing. That is why the velocity is not constant and the object is accelerating. You need to remember this thing. That is very important in circular motion. Okay. Now, what are the direction of the different quantities in circular motion? Okay. If an object is placed here and it's moving in this path, okay, following this path. So we can see that this is velocity. A velocity is always tangential to the acceleration and force. There is force and acceleration are always directed towards center of that path. Okay, okay. I have written these two things. You can read it here. You need to remember the directions of these three quantities. Okay, now examples of centripetal force. Okay, that force that is deriving the object in circular path is that called centripetal force. But you need to remember that centripetal force is a generic name. It can be any force. For example, motion of Earth around Sun or planets revolving around Sun, right? So what that force is called gravitational force. Now, gravitational force is acting as the centripetal force. In second example, we have stone whirled in a circle by means of string. Okay, the stone is whirled in a circle by means of string, which means that there's a tension. Okay? The tension will be your centripetal force. In third example, the car is turning around a corner roundabout. That is friction. Okay, that is allowing the object, allowing the car to turn around, to take a turn. In fourth example, we have aeroplane moving. That will be your air resistance. Okay, aeroplane is making a turn, right? Like okay, like this. So it will be the air resistance that will be helping it out to make a turn. And last example, we have electrons revolving around a nucleus. Okay, if you are studying your EM chemistry, then you must know that this force is responsible, okay, for the revolving of electrons around nucleus. So this is called the centripetal force at that scenario. So this was for your centripetal circular motion. Then we have projectile motion. So what is projectile motion? Projectile motion is written over here, motion in two dimensions. Okay, so we have two dimensions, that is a horizontal as well as a vertical dimension. So in most cases, you must know that air is negligible, okay, which means E would be 9.81. Okay, it would be mostly minus 9.8. So From the graph, if we closely look at the graph, so this is the velocity, okay? This is a trajectory, okay? This is the path of that object. It is a projectile. So we can say that this is a v with velocity, that is what resultant velocity, okay? The resultant velocity has two components. Is Vy, okay? Vy is what? Vertical velocity, this one. Secondly, Vx is your horizontal velocity. So these are the two velocities, the velocity components. Okay. Secondly, the height. This is the height of the trajectory. Secondly, this is the range of the trajectory. How much distance the object has covered in the whole projectile motion. Second thing to note, if you need to find out Vy, that is vertical velocity, you can find it using V tan theta. Secondly, if you want to find horizontal component of the velocity, you can find it using V as theta. Okay. Then moving on to our next thing, that looking at quite complicated, but it's very easy. I have drawn here and each instant what is happening, okay, during the projectile motion. This is at every second you can see, okay, what is going on in the projectile. So in the starting, the Vx is always like this, okay? You just need to remember the yellow arrow is Vx. You can see that Vx is always in same direction acting, okay? So Vx is always constant, okay? You need to remember this. Secondly, G. G is always acting downwards and it is also constant. Okay, G is minus 9.81 always throughout the whole journey. Okay. Now you are left with what? Vy. If you see closely, so Vy would be decreasing. Okay. It decreases so much that it becomes zero at maximum height. Okay, when the object reaches maximum height, the Vy becomes zero. So you are only left with one component, that is horizontal Vx. Then now that the object moves downwards, okay, again comes to the ground. Now Vy would be acting downward. Okay, so now Vy would increase, but suddenly it will become zero when the object hits the ground. Okay, so this is the whole journey of the projectile motion. Okay, so you need to remember three things: that Vx is always constant, Vx is the only component at max height, G is always constant and at downward, that is minus 9.81, and Vy first decreases to 0 then again increases. So this was all the projectile motion. Then this scenario was, if you see, this is a very symmetric shape, okay, regular shape. It is when there is no air resistance, okay. This is a scenario where air resistance is negligible. I previously told you. But what if we have air resistance? Okay, so the graph would look something like this. In the orange one, okay, your range would be less, and it would come down very quickly. So it would be a uneven shape of the graph. Okay, this would be the effect. I have written here range will be less due to air resistance. So this was all the projectile motion and circular motion. It was very short topic, but you need to practice a lot of MCQs to get your concepts clear. Now we will be practicing some MCQs of the topic we have covered. Okay, so first sentence states that a force F is applied to a freely moving object. At one instant, the object has velocity v, okay, and acceleration a. Which quantities must be in same direction? Freely moving object, okay. So we know that a and f are the two quantities which must be in same direction. Okay. So second MCQ says an object accelerates in a direction that is always perpendicular to its motion. They are talking about circular motion. Okay. So what is the impact, if any, of the acceleration object speed and direction? So we have know that speed would remain constant, okay, but the direction is changing. Speed would be the correct. Okay, if I draw it like this, so the object would be changing its direction at every instant. A ball is thrown horizontally in air from the top of a building. The ball is affected by air resistance. Okay, now the air resistance is not negligible. So what happens to the horizontal and to the vertical component of the ball's velocity? Okay, so the horizontal component now would, okay, decreases to zero. Now it will not remain constant. And secondly, vertical component of velocity would increase to at a constant rate or to a constant rate. Okay, if we take net air is in account, then the object would reach a terminal velocity. So it would reach at a constant to a constant value. Okay, so B would be the correct. Okay, this one is a very easy question of projectile. Okay, it rises to a maximum height, throws a ball. Okay, ball backs to your hand. They are talking about what is the acceleration value at 3 instant, and the object is rising at maximum and at falling. So I have previously told you G is always constant. Okay, and it is negative during the whole motion. So B will be the correct answer. In our last MCQ, a golf ball is hit with same force and direction and on the earth and on the moon. Which diagram represents the shape of the paths taken by the golf ball? Okay, on both scenarios. So you can see that on moon we have G value approximately 1.6. Okay, and on earth it is 9.81. So on earth the, the ball would cover less. Okay, the range would be less on earth as compared to moon. Okay, so it could be A. Okay, and every option it is the same thing. Now we need to cover that which path would be the correct. Okay, D would not be correct. The ball would come, okay, to the ground at some point. A would not be correct because you can see the shape is uneven. And B is not correct because they are taking air resistance into account. And you know that moon has no air resistance. Earth has, but moon has no air resistance. So moon path would be what? Symmetrical, like in C. And A path and earth part would be, okay, something uneven. So C would be our correct answer. So this was all about the projectile and circular motion. In next video, we will be covering some of the more past papers of combined kinematics chapter. Okay, so before watching that video, you must watch the 3 videos of kinematics. Okay, thank you.